Again, this isn't going to be a direct proof or a two-column proof. It's more of a, hey ma, look what happened kind of proof, where we're just going to play with things and good things happen. So I'm just going to start with log base y of x and saying it equals m, and then change it to exponential form. So we'll get the base is y to the power of m equals x. Now I'm going to take the log base a of both sides, so we'll end up with log base a of y to the power of m equals log base a of x. So we're allowed to do this because it's an equation, so whatever I do to one side, as long as you do it to the other side, it should still be equal. Roll down the power, and we get m times log base a of y equals log base a of x. I'm going to divide both sides by log base a of y, and we get m equals log base a of x over log base a of y. But now, let's look back at the start and go, what was m? Oh, well look at that. M equaled log base y of x. So we're just going to sub that in for m, and we get the rule. Log base y of x is log base a of x over log base a of y. Now, this rule, a can be absolutely any base. If you look at the rule where it says log base y of x equals log x over log y, well, that's base 10 specifically. But when it's a, it's actually more powerful because you can make it absolutely any base you want. And that's why that's called the change of base rule. That it's basically whatever the base is, log base y of x, you can always split it into two logs with any base that you want.